Hello everyone, my name is Saling. On my today's video, I will teach you the procedure that we need to follow to calculate or to compute the LS factor of revised universal solidus equation or RUSLE using ArcGIS. So as a principle, revised universal solidus equation have 5 basic factors or components, namely rainfall erosivity or R factor, soil erodibility or K factor, land with land cover factor or C factor, LS or slope length and slope steepness factor, and finally the conservation structure existed factors. So from those 5 factors, today I will compute the value of LS for one watershed that I delineate only for the purpose of this video. And next time I will also do another videos for all revised universal solidus equation factors. So for now, let's start by opening our ArcMap or ArcGIS software. So here I opened my ArcGIS software. So now the required thing for computing or for calculating the LS factor are digital elevation model map and the watershed boundary map only. So after having those two things, we can do some synthesis and we can finally compute the LS factor. So now we need to add the digital elevation model in which that our watershed is included. For example, it may be Awash Basin, it may be Abai Basin, or it may be the DM map of any other areas. For example, it may be administrative DM map. For example, I have the North Shore DM map. So now let's add our digital elevation model map. So here I have the DM map of North Shore zone, and next we need to add the boundary map of our study area or our watershed, which is Berissa watershed. Here is a Berissa watershed boundary map. So now we add both the watershed boundary map and the DM map of North Shore. So here we need to extract the DM map of our watershed from the North Shore digital elevation map. So to do this, we need to go to Arc Toolbox and Spatial Analysis tool here. Then extraction. Here we see extract by mask. So double click on extract by mask, and input raster is North Shore zone DM. Input raster from feature mask is the Beressa shapefile, and here we can rename and we can change the folder that our output file will be saved. So here I only change the name and Beressa DM and click OK. Then so now I can extract the detail elevation map of my watershed. So now we can clear all the file that I added for the purpose of generating DM. So remove, and I can remove this also. Then here I can generate the DM map of my watershed, and here I can zoom to layer. So this is the DM map of my watershed. So the remaining thing to compute the LS factor map is computing slope, computing flow accumulation map. So to compute the slope map of this watershed, we can directly go to spatial analysis tool, then surface, and here we see slope. So double click on slope, and the input raster map of for computing slope is the dm. Then here we can rename as bear. Then here we can change it to percent rise. So click OK. Then now I can compute the slope map of my watershed. So now I need to compute the flow accumulation. So to compute the flow accumulation of my watershed, we need to go to the hydrology, and first we need to fill. So to fill the input raster, the input surface raster is Barresa DM, and here is fill bear is my file name. Then click OK. Sorry. So now I can fill, or filling is done in this way. Then flow direction, and the input raster for flow direction is field map. Then flow direction, we can click OK. So the flow direction map can be computed in this way. And finally, the remaining thing is flow accumulation. So the input flow direction raster is flow direction map, and the file name is flow accumulation. So click OK. Now we can wind up all the procedures that we need to compute for calculating LS factor map. So the remaining thing that we need to do now is computing the LS factor by the equation generated by Griffin. So to compute this, we need to go to map algebra, and here we see raster calculator. So click on raster calculator, and on the raster calculator, LS factor map is the power of flow accumulation times 20, or slope cell size, which is 20 meter by 20 meter, over 22.1, 0.6 times power of sine slope, sine of slope, sine of a slope map, times 0.01745 over 0.09, 1.3. Then here the output raster, we can change the folder or the file name or the folder that our output raster will be saved. So for the sake of this video, we can leave as it is. So click OK. Then the calculation of LX factor is on the process. So now we can get the LX value of our watershed. This is the LS value times 100. So we need to divide this value by 100 to convert from percent to number. So equals to over 100. So click OK. So this is the LS factor map of our watershed. So if we symbolize, or if we want to convert the color or the classification of this LS map, we can right click on this and go to property, and here click on classify. Here we can change the color into any color that we want to do. So then finally we can also classify the value and the range based on our interest. So click OK, and this is the slope length and slope steepness factor of our watershed. So this is the way of calculating slope length and slope steepness factor of one watershed by using ArcGIS or ArcMap. So this is all about what I have for today. Next time we will meet with another videos done with another factors of reverse inverse Arrhenius equation. So if you like this video, you can share and subscribe my YouTube channel. Thank you for watching.